Hi friends, this is the Math Olympiad question. We are going to find all the values of a. The given equation is a square minus a cube equal to 2. Rearrange the equation so a square minus a cube minus 2 equal to 0. Now the first two terms a square and a cube, the last constant term we are going to rewrite minus 2 is equal to minus 1 and minus 1. So this minus 2 is going to rewrite a square minus a cube minus 1 equal to 0. Now we can regroup the two terms a square minus 1 and a cube minus 1. So regroup the terms a square minus 1 minus a cube minus 1 equal to 0. The first two term is a square minus 1. The last two term is minus of a cube plus 1. A cube plus 1 equal to 0. Now the first term a square minus 1 is same as a square minus 1 square. This is a square minus b square. The last term, that is a cube plus 1 is same as a cube plus 1 cube. So this is in the form of a cube plus b cube. So let us write the expansion of a square minus b square. A square minus b square is a plus b into a minus b. A plus b into a minus b. So what about a cube plus b cube? A cube plus b cube equal to a plus b into a square minus ab plus b square. So we are going to apply this identity in this a square minus 1 and a cube plus 1. So let us apply these identities. So a square minus 1 is in the form of a square minus 1 is equal to a plus 1 into a minus 1. A cube plus 1 cube is equal to a square plus ab plus 1 square. So a plus b into, so a plus 1 into a square minus a plus b, that is 1 square. Because a is 1, this is a and b value is 1, so be careful, a square minus a into 1 plus 1 square. So these are the factors. Let us replace here. So instead of a square minus 1, we are going to rewrite a plus 1 into a minus 1. Minus of this expansion is going to be rewrite a plus 1 into a square minus a plus 1, which is equal to 0. Now see, the first two factors are these are in one term and these are in the one term. Here a plus 1 is the common factor of the both terms. So we are writing a plus 1 is a common factor. Let us write all the other terms. So a minus 1, here the minus of the last factor is a square minus a plus 1, which is equal to 0. Now we can remove the bracket. So a plus 1 into a minus minus 1 minus a square plus a minus 1 equal to 0. These are the two factors. So the first factor is a plus 1 equal to 0. The second factor is, let us rearrange the second factor. So minus a square plus 2a minus 2 equal to 0. By multiplying minus 1 on the both sides of this second factor, we can remove this negative from the first term. So it is going to be right, a square minus 2a plus 2 equal to 0. The possible values of a, the first value is a equal to minus 1. This is actually the real solution. So one of the solution, we found one of the value of a. Let us find the other values. There are two values in the second factor because it has highest degree is 2, so it has two factors. Let us find one by one. There is difficulty to find the product and added value. So there is a quadratic formula. If x is an unvariable, x is a variable, so how to find out the values of x? X equal to minus b plus or minus square root of b square minus 4ac, b square minus 4ac, the whole divided by 2a. So substitute the value of ABC. A is a coefficient of a square and b is a coefficient of a and c is the constant term. So let us replace ABC in the formula. So a equal to, we are going to find the value of a equal to minus of minus 2 plus or minus square root of b square. So minus 2 the whole square, b square minus 4 times a times a, coefficient of a square is 1. So a times c value is 2, the whole divided by 2a. So 2 times 1. So a equal to minus of minus 2 is positive 2 plus or minus square root of 4 minus 8. 4 minus 8 the whole divided by 2. 2 times 1, that is 2. Now we can find out the value of a. A equal to 2 plus or minus square root of minus 4. Actually the square root of negative number, so it definitely is an imaginary complex roots divided by 2. So 4 is a perfect square, so root of 4, this 4 is 2, but root of minus 1, which is I square, root of I square, the root value is I. So it has imaginary roots, so a equal to 2 plus or minus 2i the whole divided by 2. Now 2 is a common factor, so 2 times 1 plus or minus I divided by 2. These 2 will be cancelled. Finally we have the two factors, a equal to 1 plus or minus I. The required values of a, because our equation has the highest degree is 3, so definitely this equation has the highest degree is 3, so definitely a has 3 value, either real or imaginary roots. Here one of the real root, other two roots are imaginary root, that is the complex roots. So finally we have the roots are a equal to minus 1 is the real root and 1 plus I is one of the root, then the other root is 1 minus I. These are the possible roots of this equation. Thank you.